The following is an original production of AZPM News.
Arizona Science is supported by Research Corporation for Science Advancement.
For Arizona Public Media, I'm Tim Swindle, Professor Emeritus of Planetary Science at the University of Arizona, and this is Arizona Science. Joining me today is George Sutphin, an Associate Professor of Molecular and Cellular Biology at the university, who will be the first speaker next week in the University of Arizona College of Science's annual lecture series. George will be talking about how preventing disease by better understanding the effects of aging can help us. Welcome, George.
Thank you. Happy to be here.
There are a whole host of diseases for which age is a major risk factor, and there are also many, many things that are just a natural part of aging that aren't part of a disease. How do you know where to start?
That's a good question. Just about everything in our biology changes with age, and you really have to do some work to understand where to start. That's where the basic science comes in. You can do genetic screens, you can do drug screens, try to figure out what are the important parts, what makes a difference to our late life health and lifespan.
Have you or others had success in attacking disease by attacking specific features of aging?
Well, historically, we have a reactive approach to medicine where first we wait till we get sick and then we try to figure out what's wrong and how to fix it. And the idea of starting earlier and understanding the core drivers of why we get disease in the first place is a newer prospect. And really focusing on aging is that biology. So it's a little bit newer science. We are seeing success certainly in laboratory animals like mice and worms. In humans, we don't even, up until very recently, we don't even have a way to study aging in the sense that we can do a drug test. The first ever drug test is now underway. Hopefully in the near future, we'll have that answer in humans.
What kind of a drug is it?
If you or someone you know has diabetes, they may be taking a drug called metformin. Metformin, it turns out, we've been using it for 50 years. It's very safe. It's one of the reasons we're actually starting with that one. It turns out that if you look at people who are taking metformin who have diabetes, in some ways they appear healthier than non-diabetic controls, age-matched people who are not taking metformin. That suggests it's doing something beyond helping diabetes and may actually be hitting underlying aging processes that may benefit our health.
Is insulin important for those who are non-diabetic as a part of aging?
Absolutely. It's one of the main ways we react to the things that we eat and the environment we're in and how we manage the resources that we get through our diet. Glucose, of course, is the major player that it's regulating. So which tissues get glucose? How is that turned into energy? How do we use that for downstream health? And if that's misregulated, it ends up having lots of downstream consequences.
Do you think that studying the fundamental effects of aging will change the way medicine is practiced?
Absolutely. Many people think that this could revolutionize medicine. The reason is that the way we currently approach medicine is very reactive. We wait till we get sick, then you go see your doctor and see if you can fix it. That has worked very well for ailments that tend to affect us early in life. You get a broken leg, you get the flu, something like that. It turns out that has been less effective at dealing with these late life pathologies. We can do things about heart disease, we can do things about cancer, but it would be easier to intervene earlier and prevent those things from happening. So aging, because we're taking a step back from the effect of the disease and trying to understand its cause, by intervening at that point, aging medicine really would be preventative medicine, which we talk about, but we don't really do in practice as much right now. And so when we talk about preventative medicine, aging research and longevity research really are driving the approaches that are going to shift us from a reactive medical system to a truly healthcare preventative system.
Do you have a sense for why this has not been something that people have looked at until relatively recently, or have they?
That's an interesting thought. I think part of it was there has just been a perception that just aging is what happens as we get older, natural part of life. Maybe we can't intervene in that. Though in some sense, in like the opposite sense, we've been interested in this problem as far back as we know. Some of our oldest literature is things like the Gilgamesh art literature, where the stories have him looking for immortality and seeking immortality, right? So there's been a kind of a cultural desire for increased lifespan and health throughout human history. It was probably in the 1900s when we first found something that could actually have an effect, and maybe people started believing we could do something about this. The first thing we really found was caloric restriction. What caloric restriction is, as it sounds, you reduce the total amount of calories you eat. There are other versions like fasting, where you tweak total input and maybe you eat less sugar. All of these things tend to give you a big lifespan extension and a health benefit. Toward the end of the 1900s, we had the first discovery in the roundworm, which is what I study, that if you tweak a single gene, and this was the insulin receptor gene, if you knock that down, you can extend lifespan of the worm by almost twofold. Before that, everybody thought that this was going to be too complicated. There wasn't going to be like simple interventions like a single drug or a single gene that could give you a big benefit. When this discovery was made, it changed the thinking across most of the field, and that kind of launched what I consider the modern genetics of aging field, which is where I grew up and what I work on. And so now we know we can have these big effects from simple interventions, and now we just need to figure out why and what's the best point to tweak that system.
I believe you started out in aerospace engineering and got as far as a master's degree before switching to the study of aging. What caused you to make such a drastic switch?
It just turns out I got fascinated with this problem. You know, my dad, when I was growing up, always told me that, you should go into genetics. That's going to be the way of the future. And of course, as a typical teenager, I went off and did aerospace engineering. That was what I wanted to do.
As far away as you could get from it.
So but I did always have this interest in this idea of genetics and biology. And then sometime in there, something caught my interest. I don't remember what the key factor was, but I'd always had an interest in aging, lifespan extension to some degree in the back of my head. I was among those who didn't think it was possible, and it was kind of science fiction. But when I started looking at it, it turns out that people were making progress. There were genetic interventions, drug interventions people were finding that could extend lifespan in roundworms, in mice, in other like animal systems that we use to study biology. And it got to the point where I was reading more about the aging science than I was about my space science. And at some point, the light bulb went off, and I decided that's really what I wanted to do when I grow up. So here I am.
Do you find that you have a different approach to problems than researchers who don't have engineering in their background?
Yes, though more and more, a lot of the biologists we're hiring often have what are traditionally considered more kind of hard science, quantitative backgrounds like engineering, physics, math. Biology has certainly changed over the last few decades from more of a qualitative science, an observational science, to more of an interventional quantitative science that's driven by the advances in computer science. Now we can look at the genome at the whole genome scale as opposed to trying to tweak individual genes. And so there's more of a need for people with quantitative approaches to problem solving in biology. So yes and no. Maybe then someone traditionally trained as a biologist, I take more of an engineering approach. But more and more, that is a personal type within the people who study biology. So.
Thanks for talking with us today, George, and I'm looking forward to hearing your presentation.
Great. Thank you for having me.
Our guest today has been George Sutphin, an expert on aging who will be the first speaker in the University of Arizona College of Science lecture series at 7 p.m. next Wednesday at Centennial Hall on the University of Arizona campus. This is Tim Swindle, and you've been listening to Arizona Science. You can hear more of this conversation and others on our Arizona Science segments by going to the AZPM podcast at azpm.org.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science.
This has been an original production of AZPM News.